A matrix product is built from doing multiple matrix vector products. So if we have two matrices, we can define their product if the number of columns of the matrix on the left, which we're going to call A, is equal to the number of rows of the matrix on the right, which we're going to call B. This is the same condition as we have for matrix vector products. We have to have that that the number of columns on the left is equal to the number of rows on the right. And the result is going to be the number of rows will be the number of rows of the matrix on the left. The number of columns will be the number of columns of the right matrix. So if this matrix on the right has k columns, we can call them B1, B2 through Bk. Then the matrix product is formed by taking the left matrix multiplied by the first column of B, the left matrix A multiplied by the second column of B, and so on. So we calculate up k different matrix vector products. Let's take a look at an example to see this. So here we have this matrix A, which is 3 by 2, multiplied by this matrix B, which is 2 by 2. So because these two dimensions match, the number of columns of A is equal to the number of rows of B, this product is defined, and our result is going to be 3 by 2. All right. And so the way that we're going to define this is that our matrix is going to be formed by taking A times the column 1, 3, and A times the column 2, 4. So let's compute each of these. First, we'll do it separately. Then I'll show you how to do it all together. So if we want to take A times 1, 3, okay, we're going to do 1 times 1 plus 0 times 3. So 1 times 1 plus 0 times 3, or 1 times the 1 plus 0. We'll do 5 times 1 plus negative 2 times 3, negative 3 times 1 plus 7 times 3. So this will give us 1, 5 minus 6, and negative 3 plus 21. Or 1, negative 1, 18. This will be the first column of this product. So 1, negative 1, 18. Our second column is we get by taking our matrix A and multiplying it by the second column, which was 2, 4. Okay, so this will be 1 times 2 plus 0 times 4, 5 times 2 plus negative 2 times 4, negative 3 times 2 plus 7 times 4. Okay, or 1 plus 0, 10 minus 8, negative 6 plus 28. And adding them together, here we have 1, 2, and 22. And so we have produced the product. All right, let's try looking at this same problem where we are just going to switch the order of these two matrices. So here, if A was 1, 0, 5, negative 2, negative 3, 7, this guy is A, and B now is on the left. Okay, if we look at the dimensions of these guys, B is 2 by 2, and A is 3 by 2. And now when we compare these middle values, we notice that these are not equal. So we're not able to do the matrix vector products here. They don't make sense. So what that means is that this matrix product is undefined. Doesn't make sense. So matrix multiplication can only be done in the case that the number of columns of the left matrix is equal to the number of rows of the right matrix. Let's look at two more examples.